And well, let's try to solve a problem like they already asked in IIT JEE. So, this is one of the problems you should be familiar with. And the problem is 2 point charges q and q dash, and q dash is equal to minus 2q. Okay, are fixed at a distance d from each other. Determine the type and parameters of the zero potential surface of this system of charges. When the potential is normalized at phi infinity is equal to 0, potential at infinity is equal to 0. And there are two charges. This is minus 2q and this is q. And the kind of zero potential surface they create. Yeah, zero potential surface they create. So what can be it? Uh, let's place the origin of coordinates O at the point where charge q dash is located, and you can see our x and y axis on the screen, and charge q at point A, and we need to nothing to do. We just take a point M whose coordinates are x comma y, and what will we are going to write the potential at point M due to both the charges q dash and q, and well, we can write it easily. The potential at point A will be 1 by 4 pi epsilon naught, and then for q dash the distance is simply x, because this is the origin, the distance will be simply under root x square plus y square. And for q, we can write q by distance from q, it will be d minus x. This is its x coordinate if the origin is placed at point A, d minus x square plus y square. And this is simply the distance ma from point A to M. And if at this point the potential is equal to 0, we can write here, we can solve it, and we can write something like q square x square plus y square plus q dash square d square plus x square plus y square minus 2xd, and many more steps you need to write down, and finally you need to solve it, basically this equation. And I left this burden to yourself so that you will be able to solve it in x and y, and you will get some result, in fact, like this: y square plus x plus q dash square d by q square minus q dash square, and the square of all of this equal to q dash square q square d square by q square minus q dash square, and the square of all. And put the values of q dash and nothing else, q dash, and this is the equation of and finally you are going to get a circle. I guess after putting all these values, you are going to get a circle and get the radius of the circle. That in this case, you are going to find 2d by 3, and you will have your circle in xy plane, and there is a sphere. If you generate this circle, you will get a sphere, that is your zero potential surface. So we need to do nothing, like we need to take a coordinate axis, consider a point where potential is equal to 0, write down the potential and solve it. You will get the result. And in this case, the surface of zero potential is a sphere with radius equals 2d by 3, and center of which is on the line of the axis, line of the charges, at a distance minus d by 3 from the charge q, from the charge q dash. And that means what I'm trying to tell you, that distance is this distance is minus, this distance is d by 3, coordinate of this point is minus d by 3, so this distance simply is d by 3 and radius is 2d by 3. We have nothing to do, so mere calculations are involved in this problem, nothing else. Thank you very much for watching on